everyone, this is our second video on section 5.1.2, Descriptive Statistics. In the last video we introduced the mean and talked about how to compute it and also how to interpret it. And what I would like to do now is return to the topic of mean and think about it a little bit deeper. So your book has a critical thinking question on page 271. And what it says is that in news reports and other places, you may have seen arguments like this. The average household income in the United States is $56,000. The average cost of a family health insurance plan on the individual market is $10,000. Therefore, the average family paying for health insurance on the individual market must spend about $10,000 divided by $56,000, or 18% of their income, paying for health insurance. We want to analyze this argument critically. Even supposing that the figures are accurate, what additional assumptions does this statement involve? And I want to give you a second to think about this. Basically to think about what's wrong with an argument like this and see if you can come up with some answers. Okay, so here are some of the answers that I came up with. And maybe we'll start with sort of the least technical to the most technical issues with this line of reasoning. So if we go back, the first thing that sort of strikes me as an issue, this reference to the average family. I mean, what does that mean? What is an average family? And this sort of gets back to the idea that the mean is actually pretty hard to interpret. I mean, when we see a phrase like average family, what we probably are getting at is that this family is a good representative of people, of households. But statistically, what the average is telling us is something else entirely. And if we think about the way that they're describing or using that term, the average family, what they really mean is a family that is average in all of the values that are being measured. So a family that's spending an average amount on health insurance and a family that's making the average amount of income. And obviously no family is really going to hit that. There's no such thing as the average family. And I mean, you hear jokes about this in other contexts as well, like the average family with their 2.1 children and their 0.7 dogs. Right, we understand that the mean, those numbers, aren't actually describing a realistic family. So I don't even know what sort of family this is supposed to be describing. A second issue, if we go back to that statement, is that we are comparing means that are being computed from two different data sets. And you can tell that by the wording here. Household is the first one. So for this first average, 56,000, we're talking about anything that qualifies as a household and has an income. So the average household income in the United States is 56,000. Now I'm not really sure what counts as a household and what doesn't, because it's going to depend on the study that the statistic is coming from. On the other hand, the second mean that they're referring to is the average cost of a family health insurance plan on the individual market. So we're not comparing to all of the households with income here. We're talking specifically about families. So maybe that's what we meant by household, but maybe not. Families purchasing a health insurance plan So not every family chooses to purchase a health insurance plan. Not every family can afford to purchase a health insurance plan. And these are people who are not purchasing them, not getting them through benefits at work, but they're purchasing them on the individual market. So many types of jobs, full-time jobs with benefits, include insurance as one of the benefits. So if you have a position like that, you aren't going to be buying health insurance on the individual market. So you're being excluded from the second mean, but included in this first one. People buying health insurance on the individual market are more often people with gig jobs or lower paying jobs that don't count as full-time and don't come with benefits. So my second issue with this statement is that we're comparing studies or data sets where the individuals being compared aren't the same. Which means that our comparison isn't going to be very meaningful at all, because I'm really comparing apples and oranges. Right? In one of these numbers, the individuals were any household with income, and in the second one, the individuals were specifically people purchasing family policies, so let's just say families, purchasing insurance on the individual market. Now, obviously, there's a lot of overlap between those two groups of people, but they're not the same, which means that it's not realistic or it's not accurate to compare means across the two samples. Okay, and then I'm going to end with one third thing, which is this division here. This is really problematic. Because what I'm doing is I'm taking one average, which remember I get by adding up a bunch of numbers and then dividing by the number of samples, and I'm dividing it by another average, which was computed the same way, and I'm saying that somehow that gives me an average of the proportions between the two. And that's not the way it works. So my third and maybe most technical point or issue with this is that to compute a percentage like this, maybe I'll say to compute the average percentage, which is a reasonable thing to be interested in. I mean, the question that they're trying to answer of how much the average family, whatever that means, is spending on health insurance is a good question to look into, but you can't get it this way. To compute the average percentage, you can't look at the percentages for the averages. And I want to explain this to you in two ways. Let me start with something concrete. Let's go back to our PowerPoint and our example where we're just saying, yes, okay, I accept that the household income averages out to $56,000, and I accept that the average amount spent on a family health insurance is $10,000. Even from that, I can't conclude that on average these families are spending 18% of their income paying for health insurance. And let me show you an example. If I can come up with samples where it doesn't work out that way. So let's say that I have these 5 incomes, which do average out to the $56,000 that I started with. and I have these amounts spent on insurance, which come out to an average of 10,000, like I started with. If I compute the percent that each household is spending on their insurance, I do not get 18%. I get that the average amount that each is spending on insurance is 21.59% of their income, which is much more than the 18%, or really the 17.86% that you get by just dividing the averages. And there's nothing special about this sample. I mean, you could easily come up with examples where you get other numbers as the percent spent on insurance, depending upon what values you use. And if you look, maybe one thing that's noteworthy is that in the percent spent on insurance, just because of the way I set it up, you have this one extreme value where one household is spending 50% of their income on insurance, and another one is spending less than 3% of their income on insurance. And that's going to not mess up, but going to influence my average, my mean, because remember, a mean is impacted by outliers, like this 50%. Okay, so hopefully this convinces you that this type of math doesn't work out. You can have two samples that have this average for the income and this average for the amount spent on insurance, and the percent that you get spent on insurance, the percent of income spent on insurance, doesn't come out to just 10,000 divided by 56,000. What I want to do now is go back over to my notes and give you an algebraic reason why. And what it really comes down to is the order of operations. Okay, so to make life simple, let's suppose that instead of 5 individuals to keep track of, let's say I just have 2 individuals. And let's say that their annual income one has an annual income of A and one has an annual income of B. And then the cost of insurance the first individual has a cost of little a and the second one has a cost of little b. Okay, so let's compare the two percentages that we might be interested in. So if I compare let's start with the percentages spent on insurance. For the first individual, this would be little a over big A. And for the second one, this would be little b over big B. And, if I wanted to write this as a percentage, I'd have to multiply by 100, but really these are the ratios that I'm looking at. So the average percentage spent on insurance well, it's just the average of these two numbers, so I add them and divide by 2. Let me write that as 1/2 times their sum. Okay, and let me box this because we're going to want to compare this. What if I use the method that was used in whatever article this quote was taken from? What if I just look at the averages and try to take their ratio? let's see what we get. So the averages for income, that would be A plus B over 2. And the average amount spent on insurance would be little a plus little b divided by 2. So when I looked at the ratio, or the percentage, of the average amount spent on insurance divided by the average income, I would get little a plus little b divided by 2 divided by big A plus big B divided by 2. These 2's cancel, so I get little a plus little b divided by big A plus big B. Okay, so here are the two fractions or ratios that I get. I get 1/2 A over big A plus B over big B. If I do this the correct way, if I compute the percentages that each is spending on insurance and then average them, and if I take the strategy that the article that quote was taken from uses, I would just get A plus B over big A plus B. And the important part is that those are not equal. I get two different answers. So if you're trying to talk, let's go back to the original question. If you're trying to talk like this is about an average percentage that people spend paying for health insurance, or other things where you might want to compare average amounts and think about percentages or ratios, you cannot just compare the two averages. You have to look back at the individual data values, find the percentages for each data value, and then average those to actually get a meaningful result. Okay, and that is all I have to say for mean. On Thursday, we'll come back and talk about one more descriptive statistic called the standard deviation, and then we'll move on to the idea of skew.